Hello, and welcome to the inaugural podcast of the Art of Engineering. My name is Chad Harden. I am a structural engineer broadcasting from Irvine, California. You can visit us online at www.taepodcast.com. Well, I'm so excited to start this podcast, which developed recently as I began to reflect on my own design process in developing structural calculations and design plans, which I think constitutes an artistic process. To start out, the goal of this podcast is to document the evolution of a career in engineering. We will be looking at the life of an engineer from college to early design and technical duties to the perspective of more senior design engineers. The format for this podcast, we're going to interview engineers from various disciplines within engineering. Could be civil engineers, structural engineers, geotechnical engineers, and others, as well as maybe some non-technical interviews with artists themselves, how they see industrial engineering affecting their artwork. We'll see how it goes. And I'd also like to really promote the STEM to STEAM movement. If you're familiar with that, it's science, technology, engineering, and math, and getting that so much more prevalent in schools today. But there's also a STEAM movement that puts an A into the STEAM, which is for art. So there is a crossover between science, technology, engineering, arts, and math. And I've come to see that in my own work, and I think it's an interesting take on a podcast. And with that, I have our first guest for this podcast, and that's going to be Clint Isa. Thank you, Clint.
Oh, thank you for having me. Happy to be here.
Clint is with Diaz Yourman and Associates in Santa Ana. He's been there for 7.5 years, and he's also the chair of the Geo Institute, which is a branch of the Orange County ASCE branch.
Correct.
So welcome. Thank you.
Oh, yeah, like I said, happy to be here and very excited about this.
So Clint, just to start it off, I have a quote, and I'm actually in the middle of a bridge widening design right now, and it's very exciting for me. And it's a book I'd highly recommend, Displacement-Based Seismic Design of Structures. The authors are Priestley, Calvi, and Kowalski. Those who have done a lot of bridge design would recognize Priestley for sure has an iconic book in the bridge world on seismic design. But on the first page of this book, there's a quote from Hardy Cross, who developed the Hardy Cross method, which in the 1960s was how they analyzed indeterminate structures. It was basically a method to analyze that. His quote is, "Strength is essential, but otherwise unimportant."
Oh. Very good.
Which is true, because a lot of the design we do, and again, I'm a structural engineer, you're a geotechnical engineer, but not letting things displace, but acknowledging that they will move is a hard concept I think that students don't see enough of in school, and a lot of the work we do is displacement-based design.
Okay. Very good. Now, Hardy Cross, was he involved with virtual work at all? Or am I thinking of a different guy?
Well, now you're really testing me.
Okay.
There was a day when every engineer knew how to do virtual work and indeterminate analysis by hand, and there's a whole tabular approach to basically knocking down these numbers to a point where you've got the answer. As I recall, the principle of virtual work involves literally a virtual load, a unit load, and you have to balance the internal and external energy, and you can also superimpose the reactions and displacements of various structures together to make up the actual structure. While the moment distribution method, you apply the actual loads to a frame or some other structure, and you iterate to a solution. And it's a very efficient method. I think in school we had to do 2 or 3 or maybe 5 iterations on the analysis till we finally got an answer.
Okay. Yeah. All I remember from my college days was one of my professors in structural engineering. His name was Professor Felton, and he, I think, did a lot of his research in virtual work, and he preached it religiously. So right. I was wondering, it's about the right vintage. So I was wondering if there's any crossover from there.
So Hardy Cross was the developer of the moment distribution method, which I think is different than the virtual work, but I'd have to study a little bit back with my textbooks to tell you the differences.
Well, next time I'll bring the book along that the Virtual Work Bible, and we can
Sounds good.
We can chat about it.
So tell me a little bit about your where you started at school and kind of your experience so far in industry.
All right. Well, I guess we can do what's logical and start at the beginning. Did my undergraduate work at UCLA. My goal has always been to, my goal always was to get a master's. So after doing my undergraduate work, I was pretty fed up with school at that point, and like any other 22-year-old, ready to go out into the world and start making money. So I cut my engineering teeth at NMG Geotechnical in Irvine. I worked there for about 3.5 or 4 years, and decided that at that point I was ready to go back and get my master's. So I went back to school, got my master's also from UCLA. It was sort of a long process, but eventually got there. And after having completed the master's, I went to work at Diaz Yourman. I've been there for 7.5 years. I'm working there as a project manager. We are geotechnical engineers. The name doesn't readily imply it, and it's not like we're a huge company where you know the name and know geotechnical engineering. Although I'm not really sure that even the layperson knows who all the big geotechs are anyway. But that being said,
can I ask before we go further? So you were working and you did your master's at the same time?
It was a little bit of both. So NMG being in Irvine, and then when I first started my graduate coursework, I was doing work part-time, school part-time, and the structure of the classes at UCLA were conducive to being able to do that. The problem is that going from Irvine to Los Angeles 2 or 3 days a week really starts to wear on you.
Right.
I had some. It wound up being too much for me to handle, so I made the decision that in order to really devote myself to getting the master's, that I was just going to have to put work aside for a year, and then go back in and get the master's full time, so I could focus on it. That's part of the reason why getting the master's took me upwards of about 5 years, even though it's a 1-year program, is because I started first by going to classes part-time, and then having to take breaks here and there. So until I really got in and started doing school full-time, it just took forever to finish.
Right.
So it's I've had several younger people who've come out of undergrad ask me, do you recommend working part-time and going to school part-time? And if you can do it, great. All I know is that for the conditions I was dealing with, it wasn't for me. So,
okay.
But don't let that be a standard for anybody else, I guess is my point.
And what was your goal for going to get the master's? Why did you choose to go?
It was always something that I had wanted to do from the time I was young, like 9 or 10 years old. I just always assumed that you go to school. If you're in engineering, you get your master's because it's just what you do. So I was just always kind of on that path, but I think I picked up a greater appreciation for just what you get out of your master's now that I got the master's and have been in practice for a while.
Okay.
You just get a better appreciation out of the engineering, and you get a more in-depth perspective of what you do once you've got the master's. And I think that appreciation and what you take out of it is probably a little bit magnified if you have a little bit of time in between undergrad and grad to work for a bit.
True.
I know there's a lot of people who just want to get the school done with,
right.
And there are a lot of people who want to get out and just because they're tired of school and want to make money, like myself.
Right.
But I think that I would advise people, if you're planning on getting a master's, get out in the field and work and practice for a couple of years. You'll get a lot more out of it that way.
Mm-hmm.
So
good.
Yeah.
Good advice. There's always the flip side, and you hear both perspectives.
Yeah.
And I think talking to younger engineers or people that are not even engineers yet, but still in school, they're like, "What should I go to grad school or not?" And my advice is always, "Well, what do you want to get out of it?" Because I think I did the opposite. I finished my undergrad and then right into grad school, and but I felt like it was something that I wanted to accomplish, and I don't think I realized it at the time. But having gone through the graduate program, you learn so much about just problem solving in a way that is so much more advanced than you get in undergrad. And I feel like right now I could probably accomplish anything that I need to from a design perspective, having gone through that. I know the tools, I know how I learn better, I know where to research, and it's something you should do if you feel like you want to do it, but not that you have to.
Yeah, I think that those are all really good points, and I agree with a lot of them. Just the ability to take problems and having the tools that you need to not only just do the job at the practicing level, but to do it well. I think you get a lot more out of the masters from that end. So, yeah.
So you've been practicing for some time. What at this point is easier for you?
Well, I don't know necessarily that any of it is ever going to be legitimately easy. You and I were talking before we came online about just the evolution and how things go from the time that you first start out to the point where I think you and I are both at. We're about 10, 12-ish years in, somewhere thereabouts. And what has become easier is making judgments about what should and what shouldn't work when it comes to engineering. Mm-hmm. And one of the principles at Diaz Yourman is one of the founding principles. He's always said that you can do all the analysis there is till you're blue in the face, but in the end, does the result make sense? Right. And when I was first starting out, I never knew if the results that we're getting made sense. And once you start getting through your career, and it just comes with experience, eventually you're going to get to the point where you're going to say, all right, somebody's going to put a piece of paper in front of you that's got some analysis results on it, and you're going to look at it and you're going to be able to say, this makes sense or this doesn't make sense. And I think that's the part of it that's become easier, is being able to make the judgment of, you almost kind of need to know know what the results are going to be before you get them, because that sort of helps you cross-check, right, and make sense, and really you come up with the best designs that way.
Yeah, I think along those lines that you're at about 10 years and beyond. That's what we were calculating at 20,000 hours. Right. I heard on a commercial once. I don't know, it was for a car commercial, I think, and they said it when you're a master when you've got 20,000 years, or 20,000 hours of experience, and at that level, you do find that you pretty much know what is constructible, what will work, what will pencil out before you really crunched any numbers, and then it's the backing it up with calculations. Obviously, you might change that, refine it by 5 or 10%, probably. Yeah. But checking the results, does this make sense, is really only something you learn by watching somebody else check and see if it makes sense. Right. There's definitely a culture of good practice that has to get passed down. Yeah. Well, I think this would be a good point. We'll take a quick break, hear a word from our sponsors, and we'll be right back.
Sure.
So this advertisement is for all the civil, structural, and bridge engineers out there. The design of reinforced concrete channels and boxes is very time-consuming. LionStar Engineering has developed an automated finite element program, EarthSuite, for these features, including design of retaining walls on spread footings or piles. The program supports design for ASCE, ACI, AASHTO, and Army Corps criteria. The real-time saver and cost benefit for using this program is the visual demand and capacity diagrams, which makes selecting economic reinforcement patterns easy, and the program designs all reinforcement cutoffs. In my own experience, there are very few programs out there which support LRFD design of bridge abutments, so I've personally applied the retaining wall module for diaphragm-type bridge abutments, which works very well for closing in on a pile layout quickly. The results are presented clearly and transparently, and the user manual documents specific design assumptions. Check out the EarthSuite program, output, and photos of sample projects online at www.lionstareng.com. Okay, so we're back, and with this part of the second part of our podcast, it's time to do a whiskey tasting. And what do we have today here? This is the Alberta Rye Whiskey Dark Batch, and it's a Canadian whiskey. It's a 95% rye mash bill. Clint and I are both big whiskey fans, so that's why I've incorporated it into the podcast.
For which I'm grateful.
And we got Glencairn glasses, which are great for tasting whiskey. It's pretty dark.
It's got a good nose to it.
Oh, cheers.
Cheers.
I think you're a fan more of scotches, right?
Yeah, that tends to be I already feel like the bass coming through my voice more now. Yeah, I do tend to prefer the scotches, but I'm a fan of whiskey in general, unless it's very, very terrible. And even then I will probably still drink it anyway. I'm still very much a novice when it comes to being able to identify various flavors and notes and this and that.
Me too.
In the scotch or whiskey that I drink, but I enjoy it, and I think it's more often not just about the company that you're with. That sometimes it'll make a bad scotch not so bad.
Right.
So,
no, I definitely feel like having some whiskey with a friend. It's like 10 times better than if you're just gonna have something like on a Friday night or something on your own.
Right. Yeah. Well, very good.
Well, we left off, and I was going to ask you a little bit more. What do you enjoy most about the engineering process?
When we were kicking around this idea of the podcast, and then you sent me the list of items that maybe we can talk about, that one being one of them on the list, it took me a little while to really think it through and figure out, all right, well, what do I enjoy about the engineering process? And what's weird is that I'm coming to appreciate the actual process itself more.
That's interesting.
Which is kind of I don't know if it's good or bad, but I think I'm getting a better appreciation for everything that goes into engineering a project.
Right.
So, for example, this ties in a lot to what you're talking about with the 20,000 hours or however many thousand of hours that it takes for you to get to the level of being considered like an expert at something. I think that's what I remember reading in the Malcolm Gladwell book, Outliers.
Okay.
And I know that's not a concept that he came up with, but it's something that he referenced in that book. And he points to a lot of examples of people getting to the expert level at very young ages. They tend to be the ones who sort of they tend to be game changers. So I think one of the more pointed examples that he had in the book was Bill Gates. All right, so because of all these very many circumstances that Bill Gates went through when he was younger, he got to the 10,000 or however many thousand hours of coding at a very, very young age. So that sort of leads into him becoming a pioneer in software development, because he got all that stuff at a very young age. So circling back over to the original question about what I enjoy about the engineering process is, now that I'm at a point now where I've been through about 20,000 hours worth of engineering work as a practicing professional, you have gone through the point where you are bogged down in calculations. And I don't even want to say bogged down in calculations. Your focus is in calculations when you first come out of school, right?
Right.
And all you're trying to do is get these calculations done so that your project manager can keep everything moving and everybody stays happy. Okay, you don't quite have the perspective of everything that goes into the project. All right, a couple of years goes by, you start to get your feet wet in the project management side of things, and that's where you start to get the exposure to the full scale of what goes into a project. All right, you're not only focused about in my case, the geotechnical engineering analysis. Okay, now you're starting to get into, all right, well, we as geotechs, we come up with all these numbers, and then we tell the structural engineer, we produce a report, and then it goes out the door, and what happens with it. Now you're at the point where you're starting to get the interaction with the structural, you're getting the interaction with the architect and whomever, and you're starting to get those outside perspectives on what else goes into making a project happen.
Right.
Is kind of really opened my eyes.
I think you can understand the big picture and begin to craft a solution collaboratively with people.
Yes.
Rather than do this task and then do this task because somebody told you to.
Right. You're not just, exactly, that's a perfect way to put it. You're not just going through the motions of of doing analysis, because that's what you're supposed to do. You are either doing it yourself, or once you get to 10 years, you can hopefully start delegating.
Mm-hmm.
But these things are being done with a purpose, because you kind of already halfway expect to know what the answer should be to the problem before you go through the analysis.
Right.
So
I think, and there's also a true artistic part to it, where you may, like I find I'm sketching something, right, with a pen and paper,
mm-hmm.
in a way that I'm communicating an idea through my own drawing to somebody else that I'm going to scan to a PDF and send through email, right?
Right.
But that there's making it easy to understand, communicating an idea, and sometimes it's communicating, with communicating with a picture, and that is truly an art form.
I could not agree with you more. It's an art that I have still not perfected by any means, but it's something that I've started to understand the importance of more lately. Mm. So like in the past 5 years, realizing that sitting down, coming up with a sketch that is legible and that communicates all the things that need to be communicated for somebody to easily understand,
right,
that takes practice, and it takes a little bit of talent and imagination, right, sometimes, right, too. So yeah, it's there is art in what we do, in spite of what I think the average layperson sort of looks at an engineer and like, oh, it's just a nerd that likes to, right, punch numbers into a calculator or a computer.
Right,
you
right.
know, it's there's more to it than that.
Well, maybe on the lighter side, what is your favorite work of art or type of art? What do you enjoy?
Oh, when it comes to art, one of my passions outside of work is sports. You know, I grew up in the South. Sports are a big part of culture in the South. And so what has been interesting to me in an artistic way is to see a professional athlete, and you can pick a sport, okay, to get to the level where you're at when you're a professional, who gets paid money, and really the guys who are at the very top of their respective professions and sports and whatnot. You have to go through so much of the repetition, the technique, and those sorts of things. And you go through those, the younger you can get through those, and the more effort you put into that, the more that just becomes rote repetition, okay?
Right.
And then that's when sports start to become an art. Just to see somebody go from having put in all the work and then maximizing their talent to the point where they can do whatever they want. Let's say, Steph Curry seems to be a really great example these days in basketball. He just moves at a different pace, and he's seeing everything what seems to be differently than everybody else. And it's just really impressive to watch, okay? And it's kind of goes back to what we were saying about the evolution of an engineer from a technician to an artist.
I hope at some point we get some audience questions or people emailing us with questions to talk about. Since this is the first one and we don't have any.
Got to start somewhere, right?
I don't know if you have any questions for a structural engineer.
Boy. I just kind of wonder in general how crazy we drive you guys with what probably seem like recommendations we pull out of a hat sometimes.
No, I don't think I think I've come to understand, and maybe that would have been my take on it, after just being in engineering for a few years. But now it's all about the communication and recognizing, even within our own disciplines, what one person defines a terminology or variable could mean something very different to somebody else based on their experience. So when you come up with a earth pressure that seems high, my first response isn't that's too high because it's not what I'm used to. It's, well, what went into that? What are the assumptions? Maybe there's a factor of safety there that we can just say, that was your assumption. I have my own factors of safety I'm required to provide from code provisions, and now we're talking apples to apples.
Yeah.
So I think that's been my first response since, and actually in school I did a lot of study on soil structure interactions. So I may be on average more adept at crossing the boundary there and knowing where you're
Probably
coming from.
So, yeah.
But I think just I think your question was, what do you guys drive us crazy? And the answer is no. I think if you're a good engineer, the first thing is to pick up a phone and call the person, not stay in the box of, well, I've got these high design pressures, I might as well just go ahead and design to 100% without asking any questions.
Yeah.
That's the problem, I think, on both in any field.
Yeah, so communication goes a long way towards making projects go more smoothly.
Right.
It's not always limited to just geotech and structural. I think oftentimes the people that hire us, so in some cases the architect or general civils, those sorts of companies, they don't always understand what we do as well. And I think to a certain extent, maybe it seems like what we do is just kind of black magic. Oh, geotechs, they collect these samples out of the ground and then they tell us this is what you need to do. And
right,
without the understanding, and not necessarily saying that an architect needs to go and get a degree in geotechnical engineering to understand
right.
it, but just having an appreciation and a basic understanding of what we do and where we come up with our stuff would go a long way towards helping projects go more smoothly. You get rid of the you probably don't get rid of the doubt and the second guessing, but it just make things go a little bit more smoothly. Maybe they have a little bit more faith in the designs you come up with, because not everybody's going to understand everything that you do.
Well, you got me thinking a little bit in that is one mystifying perspective, I think, as people look at geotechs, in that, and I've heard you guys talk as you do your borings, and you see the soil, and right away you can have a feeling for its strength properties, right, from the boring sometimes, just by feeling the soil.
Yeah.
To me, that is mystifying.
Yeah. It's a lot more basic than you would think, but at the same time, there's probably a lot more judgment that goes into it than you would think. I think geotech as a field is it's really unique because of how much judgment, and well, maybe that's not the case, but this is what it feels like. There's a lot of judgment and creativity that goes into what we do, because structural engineering, everything is quantifiable. Steel, concrete, those sorts of things, and the properties of those materials are all quantified.
Right.
Okay, but when it comes to geotech, we go and we sample such a small percentage of the project site compared to how much you're actually going to improve or develop, right? And so we're asked to make these judgments on what are the properties of the soil and the capacity of the soils to hold up your building, okay, based off a very small amount of data. So there's always going to be some amount of interpretation of the data to be able to come up with the recommendations that we come up with. And that's where the experience and the knowing what to expect and knowing all the tools that you have to work with, that all comes in, and it's the more time I've spent in geotechnical engineering, the better appreciation I have for the guys who have been in it for as long as 20, 30, 40 years, and just them knowing as much as they do.
Right.
There's a lot to be said for that.
Definitely. And, I learned a lot from even, starting out. Actually, I was lucky in school. I got a lot of, high school, even a drafting class, and I don't know if they even offer that anymore, hand drafting.
It was, I think, starting to phase out when I was finishing high school. In my junior year of high school, I did take a drafting class. It was half hand drafting and half CAD.
Oh, there you go.
And I'd probably have to venture a guess, but I would say on average, most of the hand drafting has probably went out the window within 5 years of that.
Well, I was so lucky. I'm still working with one gentleman, and he's been here at Baker for 35, 40 years, and he's seen it all from hand drafting to the early CAD platforms to now Windows and drafting on Windows and stuff. And I've learned so much from those designers who've seen it all, just designing and just the way they would just perfect the plans to a level of art too. And it's just so much to learn. And but I think the one thing to take away is to always be open to learning something new, no matter who it's coming from. Just observing and keeping your eyes open, and there's always something that you can learn from designer to engineer to somebody in another field, crossing over. There's all kinds of things to learn, and I hope this podcast has developed some excitement with young engineers or somebody in school that maybe think about this as a field that they may not have thought before. It's exciting and artistic and creative. So
yeah, absolutely. There is certainly an art in engineering.
Right.
It's yeah.
Well, thanks, Clint. That has been fun, and I think this was a great first inaugural broadcast. So
well, hopefully I can come back sometime, and I really enjoyed it. This was a lot of fun.
Yes.
New territory for me, and I'm enjoying it.
All right. Well, thank you.
All right.
Thank you for listening to The Art of Engineering. You can visit us online at www.taepodcast.com. Music for this podcast was made available under the Creative Commons license by Bensound. Music title Sunny at bensound.com.